Hey, Vlad here from devinsider.com. Welcome to another video. Unless you're new here, you probably know that architecture is a topic that is always on my mind. And so today we're going to talk about bounded context in practice, or something like that. And yeah, I know my voice is different. I don't know what's up with it. I feel fine, so we're just going to roll with it. First and foremost, since this is mostly a Scala channel, I feel like I need to mention that we're talking about bounded context, a DDD pattern, and not context bounds, the Scala feature. With that out of the way, let's begin right after the message from our sponsors, which is you or people like you. We're currently on the road to 500 patrons, which help me pay for an editor. Instead of spending time editing videos, I prefer to spend this time with you, for example, during live streams. Please consider supporting this channel on GitHub sponsors or Patreon, whichever you prefer, and thank you if you already do. All right, now, domain-driven design has a concept of a ubiquitous language. In a nutshell, it's about all the stakeholders using the same language, which should also be visible in code. We're talking about a couch versus a multi-bot supporter. After some time, it became clear, though, that the devil is in the details. We can't build a single unified model for the entire business domain because different departments of the business view those domain entities from different angles. And so we need a separate model for each view, aka bounded context. As in most of my videos, I'm on Windows and I'm using WSL with Ubuntu 20.04 inside of it, and I'm using shortcuts to control the Windows Virtual Desktop feature, so I can go to Windows like this and back to Ubuntu like that. So what we're going to do is I'm going to go back to Windows, and I already have a famous blog by Martin Fowler called Bounded Context. It's almost 10 years old, and we're going to have a look at this picture. We have two different contexts here. We have the sales context and we have the support context, and they have their individual entities like pipeline, opportunity, territory, salesperson, and the support context has ticket, defect, and product version. However, they also have entities that they kind of share. They have the two different views on the customer. They have two different views on the product. And so what we're talking about today is how we can have essentially different views on the same entity. In particular, I was very interested how we can reuse exactly the same names for them. And clearly the answer is packages or namespaces, but the devil is in the details. So today's video is essentially an experiment that I ran on that TODO app that we have written and rewritten many times. Initially, we've written it in the cake pattern videos, and then we have rewritten it to the tagless final style, and then eventually into Zio. What we'll do today is I'll show you around in the app, and I'll basically show you the diff of the two commits that I created on this separate branch. The link is obviously going to be down in the description, and you can go over here, click on contribute, and then compare. Maybe I will also include this link over here so that you don't have to click anything, and you can just scroll down and see the diff. One last thing that I would like to mention is that this whole thing was basically an experiment. It's like an over-engineered version of a simple rename refactoring. So let's go back to Ubuntu. I already have it cloned over here. So if I just go to my dev directory, which currently has only Zio to do, I'm going to go over here. And as you can see, I'm on the divide and conquer branch. And I'm going to do, by the way, this is a horrible name. I really had no idea how to call it. I just called my commits divide and conquer. Essentially, in the first commit, I simply renamed stuff. Right? I simply rename stuff, but then I noticed something that kind of forced me to do this thing. By the way, my dotfiles are online, so if you want to check out this alias, then you can at your own pace. Okay, I'm going to include the link in the description. I cannot assume that you have seen those videos, so I'm actually going to walk you through the entire app, and we're going to demo it a little bit. So as you can see, the last commit was like 8 months ago, and it was just the, some dependency updates. And I pretty much did the same thing right now. I call it housekeeping. It's basically dependency updates, a couple of refactorings. I couldn't resist. I'm not going to show you this. It really doesn't matter. In fact, like this commit actually went to the main branch. And also I have another alias like this, which displays it a little bit shorter. And so let's start by having a look at the initial version. Like essentially, it's the whole thing that we're doing today. It was just a big refactoring, so semantically nothing changed. But still, let's actually go and check out the main branch, GCM, like this. And I already have it open in VS Code over here. I probably should, recompile stuff, recompile workspace, whatever. Okay, so this is a dependency graph, and it looks complicated, but it's actually not. Essentially, we have a core at the top. You can pretty much ignore this whole thing, and then we have two ways to deliver the app, which is via HTTP or simply in as a terminal app, and we have two ways to persist data. One is with a in-memory thingy, and another one is with a Postgres database, and we used Skunk for this. And because of this entire combination, we essentially ended up with 4 different applications. Basically it's all the combinations, okay? And I use kind of numbers here to denote like these layers, okay? So this is like the layer 1, the core, and this tiny thing that you can pretty much ignore. All of these things are on the layer 2, which is why we have the number 2 over here, and all of these things are at the level 3. Okay, so what we're going to do now, I'm going to take one of them, and I'm simply going to run it. By the way, this is how I generated this graph. All you need is bloop and graph width, pretty much. And I removed like the test projects, and I removed the the root to do project. Okay, so what we're going to do is I'm going to start SBT real quick. I'm simply going to run some tests just to show you that we actually have tests. It compiles relatively fast because it's a tiny app, and also it's structured in such a way that everything should compile in parallel. I'm currently recording and I'm on a laptop, which is why it kind of looks slow, but it's actually super fast, especially with SBT caching. And there we go, the tests are green. Okay, let's run, for example, this one. It's the terminal app, but it also talks to the database. I currently have Postgres running in Docker. So if we go like this and we're going to do run, then we're going to see over here, let's actually create some more space. So if we do show all, then we're going to see like the to-dos that are currently in the database. I find this one confusing. Let's actually grab this one and delete it real quick. So I'm going to be like delete to do. And if we enter the wrong ID, we have some like, error handling in there. Paste the ID and there we go. Now it's gone. Okay, cool. So I'm going to quit, and I'm also going to run a different one. So for example, we're going to run this one with HTTP and also with Postgres. So it's going to be main HTTP, HTTP4S, Postgres skunk, and we're going to do a restart, which is the awesome Revolver plugin. So the Revolver plugin essentially forks the JVM and runs it in the background. So what we're going to do is I'm going to have this file over here, client.http, and it uses a cool extension where I can essentially write like curl-like thingies in here, and then I can just click a button, and it's going to send a request. And now we see all the to-dos over here, like this. So as you can see, there's like 2 of them, and I can create another one and show all again, and then we have 3 of them. Okay, so kind of like a simple CRUD to-do app. Actually, I just realized that I should probably also demonstrate how we can create a to-do from the terminal. And one cool thing about this is that I actually don't have to kill the HTTP server. I can just go like this, right? So I'm gonna launch the main, which talks to the same database. Okay, and I actually don't need to restart there. I can actually kind of just do run. Okay, and so if I do show all, we're going to see like exactly the same ones. Okay, so for example, create, and I'm going to say, I don't know, write script, and it's going to be 2022. Today is, well, we have March, and I believe today is 27th, and let's say it's 14/20/26, which is 1 minute from now. Okay, so now show all, and there we go. So Sunday, March 27, 14/26, write a script, and if we go and click on the show all over here, then we're going to see write script. There we go. Cool. So I'm actually going to quit this one, and I'm also going to stop the server over here. Let's clean this. Let's go over here. Let's close all of this stuff. Let's open the to-do and do this like that. We actually don't need the console right now either. Okay, so the to-do over here is scoped in the CRUD namespace, and I always use packages like this, and this is actually very important for this video as well. It's actually very important that this to-do is not scoped globally, and we're going to see this in the upcoming change that this is going to become more important. Essentially, this is like the whole topic of this video. You should never have a global view on something like a to-do. You should always have it scoped into some bounded context. Let me create some more space. Essentially, a to-do is just an ADT, and this is kind of like the problem. When I was recording the Tagless Final playlist, I realized that when I was folding on that ADT, which is something that you really want to do with an ADT, something felt wrong, because usually when you fold, it's a catamorphism, right? So you destruct or deconstruct or destroy your ADT. And what I noticed is that right afterwards, I was forced to reconstruct it again. And so I actually made an entire video about this during the Tagless Final series that you might want to check it out. But the TLDR was actually that you shouldn't always need to use fold, because there's a difference between like pattern matching and folding. Because when you pattern match, you kind of have the access to the, to these type like existing in data. But when you fold already knows which one it is. And so because when I switched to fold, the fold was running something something, and then it was reconstructing something for me. And so I realized that I should not have used the fold. But actually, I did not arrive at the final conclusion. What I should have realized in that video, that not only should I not have used the folds, I should not have used the ADTs. And the reason why I use the ADT here is very simple. There's actually two reasons. One is that in Scala, ADTs are so convenient. It's so easy, especially in Scala 3. Look at this. It's so convenient. So whenever we model something, the first thought that we have is, oh, let's go and use ADTs. Okay, but it's not always the right choice. And the reason I kept this is actually because, so if you go to the boundary, which is just a trait for the business logic, it's just like it's not really FS8, but essentially like this is the business logic and this is just the trait, so that the the delivery mechanism can just use this trait to call functionality on the core of my application. And I did this basically in the name of don't repeat yourselves, right? So if you look over here right now, like I have dedicated methods for like create one and create many, and they call functionality on a gate. A gate is just a facade for everything that the core needs. In this case, it's just a database, okay? So I'm calling like create many on the gate over here. I'm calling like update many on the gate, right? But however, if we go back in time, like this and like this, I believe we basically need to go to the very beginning like this. Okay, so over here I had write many that looked like this. Okay, it basically said, okay, like as long as this is some version of the to do, I can just call write many on the gate. And so from create one, I was calling create many. From create many, I was calling write many, and I was doing the same thing from the updates. Okay, so over here I was just calling write many. Okay, so this was the only reason why I needed it. However, if you were to look into the Postgres gate, for example, and we do the same thing, right? So we kind of like go back in time. This is essentially a fold, right? So I deconstruct it, which is fine. However, if we go like into insert one, if this was a fold over here, I would need to reconstruct one of the instances after I deconstructed it, right? So I deconstructed it, and then I'm constructing another instance, okay? And this kind of told me that well, not at the time, but right now, it told me that they actually have nothing to do with each other. These are like two different bounded contexts, and here we are. Let's go back to the to-do, and we're gonna close everything else over here. And where's my minimap? Okay, so essentially, all I wanted to do is basically to convert this thing into to-do, right? And we kind of need this to-do ID, okay? So like this, to-do ID, okay? And I would just take like everything from here, and I would go to data over here like this, and I would mark until here and paste it, okay? So basically, I wanted to have this version of the to-do, and also another version of the to-do that does not have the ID, like this, okay? So something like that. Okay, and so I'm going to remove this, and I'm going to remove that, and just for now I'm going to remove this. I obviously cannot have them in the same scope, right? Case class. Also, let's make them final, and like this, right? And let's let's move them to the left a little bit like this. Okay, obviously I cannot have like this to do in the same scope, and so I was like, okay, well, I'm just going to put this one into a different package like this. Okay, so essentially this is kind of like all I need, all I want. Okay, so I'm going to save this for now, but I'm going to go over here, and I'm going to, well, actually I'm going to go over here. So what I'm going to do is I'm going to throw this out. Okay, so grhh is just git reset hard, and what we're going to do is we're going to check out core boundary, and we're going to go down to 2. Okay, so we're essentially checking out the divide over there. Obviously, it's not the core boundary, it's divide and conquer. Man, at this point, I could have also just put in the hash. Maybe I have at completion. No, I do. Okay, so like this. We are at housekeeping. I actually wanted to be at divide. Do we need to do 1? We're at divide, I believe. Okay. If we look at the code now, then essentially this is how it looks like, right? It's just that this insert version is now in a different package, right? So it's in a different file, okay? So as you can see, like we have, to do CRUD and to do insert, and they pretty much look the same. It's just that one has an ID, the other one doesn't, right? And like these are just like helpers, okay? So the rest of the change set is actually not that spectacular. It's essentially a big search and replace. Okay, really nothing spectacular. A couple of refactorings because like I missed a couple of refactorings when I was doing like the refactoring before, but yeah, essentially it's just a big search and replace, right? So instead of to-do.data, for example, I'm doing like insert.to-do and so on. Okay, let's quit out of here. Let's come back over here. And again, it's really important to understand that even though this sort of looks like a global version of a to-do, it's not. It's always scoped to some use case, like CRUD in this case. I actually used to do this differently. I used to have a subproject called domain even above core, and it would contain the so-called business agnostic logic, but I believe this was a mistake. In any case, why are we here? We are here because of this thing over here. So we have tests for the boundary, and we're here because of this thing. I found it weird that whenever I was in the CRUD bounded context, that I had to access things from insert, especially things like this. Like for a beginner, like if this thing doesn't compile, it's really not obvious, you know, to see like how to fix this. This is like, okay, there is no arbitrary. Well, why is there no arbitrary? Well, because the arbitrary is not, the arbitrary currently is over here, right? So it's now it's in insert, right? I just moved it, right? It's for this one, so it's supposed to be here. And so with these namespaces was like this version of using the packages. I always wanted to arrive at this thing that your code compiles if you put it in the right place. And so this did not feel like it was the right place for this test because I had to do this, right? So essentially, if you search for insert dot, you're going to find like way too many things, right? You should never do like insert dot. And I'm actually going to demonstrate the issue that I'm having with it is this because it's a special case, right? And it shouldn't be, okay? So I'm going to go to like some random place in the code, okay? So the thing is that when you're dealing with scopes, like imagine having two scopes, any kind of scopes. It could be like a def inside of a def, or a class inside of a def, or I don't know, an object inside of a package, or whatever. Any two kinds. You can always look up, but you can only sometimes look down. Let me actually demo this, okay? So let's say we have a def over here. I'm going to use the curly braces, even though we're in Scala 3 and it's not necessary, but I believe it's more visible like this. Okay, so let's say that this is like the outer scope, okay? And inside of it, we have like a variable access1, and the value is going to be 1337, okay? Inside of it, we're going to have another scope. For now, it's going to be a def, okay? But we're going to demo it with the other one as well, okay? And so inside of it, I'm going to have access to. We're not going to care about name shadowing right now, so I'm going to do 1 and 2, okay? So this one is going to be 1338. Now I'm going to try to access 1 from this inner scope, right? And I can, right? So I can just do like this, access 1. Okay, so this thing is visible, like this thing is visible over here. However, the other way around, it doesn't necessarily work, right? So I cannot do, you know, some like b dot access to. I mean, I could like sometimes, and this is exactly the point, right? So if I save this, obviously it doesn't work because it's going to say like, hey, A is a unit, like it doesn't have access, okay? So like sometimes it works, right? So if you go over here, for example, and if we go do like class, okay, it still doesn't work, okay? However, as soon as we change this to an object, then all of a sudden somehow magically this works, right? And by the way, the Scala compiler has rewritten it for me, but you understand like the scopes here now, right? So for example, if you have this constellation, when you have an object inside of a def, then obviously it works, right? It also obviously works for, you know, objects, right? It also works for, well, it should be a column now, like this object. It also works for packages, for example, right? Package A. So this is, by the way, an incremental compiler a bug in Zinc. So I'm going to use like C, for example, over here, like this, and it's going to work. And because it's all based on names, right? It's all cached based on names. And it happens all the time, actually, even though it's 2022. Let's now go inside over here and make it a package. Okay, it's also going to work like... Oh yeah, so again, it's another, so we're going to call it like D or something. And so we're going to do the same thing over here. Okay, there we go. So as you can see, it works for like objects. It works for packages. Sometimes it works with vals. It depends like if you're returning like an object and things like this. Okay, but you know, you get the idea. You can always look up, but you can only sometimes look down. And so I wanted to constrain myself with, you know, with the next commit to basically to never allow myself to look down, right? So I never want to have to do insert dot. I only want to have to do, you know, I only want to allow myself to look up and do crud dot. So let's go and check it out. Okay, so throw everything out, git checkout, divide and conquer. Okay, so this is like the top one. Okay. Now, I don't want to make this video too long because you can go and look at the diff at any time. So I want to show you only like the important things. Okay. So let's start with the obvious one, right? So now we have two boundaries. Okay. So this one, the main boundary, it doesn't have the methods for creating things. Okay. Because we have now insert and it has its own boundary and it can only create things. Obviously, I just took it out, but like the devil is in the details. So please take time to actually look at diff. I'm basically going to show you only the parts that I found interesting. And essentially there is only one. So at the end of the application where we have the dependency injection, well, over there, we're kind of like we're in the very, very global scope. And therefore, over there, obviously, we need to construct each individual use case. And therefore, it's fine to go and do insert dot over there. However, there is another spot that was sort of like a coincidence. So we have two ways to deliver the app, right? One is via HTTP, and the other one is via the terminal. And the issue with the terminal is that we kind of like implemented the routing ourselves, because remember like this menu that we saw? So if we go to the controller, which is usually how I call my delivery mechanism, in CRUD, but this one. Okay, so essentially like somewhere over here, we have like this menu, right? Like this one, and this is how it looks like, okay? And I was kind of lazy to rip out this part, okay? So essentially what I just did, I said, okay, fine, like this controller is going to have both boundaries, right? And therefore I have to do insert dot, and there's another space over here where I have to do insert dot, which is over here, right? Where essentially, like this is the part where I'm doing create, because if I take it out, it would need to have its own menu, and then like wiring those two menus like in this interactive fashion is a little bit more tricky. So I was kind of lazy, like this whole project took already like almost 2 weeks because I can't do this full time. Okay, so I was just kind of lazy, and therefore if we do like insert dot, we're going to see that we have this in the controller, and therefore we also have this in the controller suite, right? So when I'm writing tests for this controller, I needed to inject this second boundary, right? This one. In fact, it was actually kind of funny. I actually didn't need to inject this boundary. Let's actually go and have a look real quick over here. At first I thought, okay, well, maybe if I don't need to inject the real boundary, then maybe this task is in the wrong place, right? So maybe this task should be inside of insert, right? Because I'm basically testing the insert part of the CRUD controller. But it was still the CRUD controller, and so I decided to keep it here, and I think it's fine that it goes like down. Okay, in fact, there's like a helper method that actually kind of runs like all the tests, and as you can see, like it doesn't even need the real boundary. However, this is the CRUD controller, so it does test functionality on the CRUD controller as well. If it didn't test the functionality on the CRUD controller, I might have moved it down. Okay, so for example, if I scroll up, it's going to use, this one doesn't matter. This is a create. Like, for example, this one. So over here, I'm doing, okay, no, this is still a create. This is also a create. I was hoping that actually at some point, I don't only have a create. Well, yeah, I don't only have the create, because I'm also seeing like, I'm doing like a show all somewhere, probably, hopefully. I'm thinking right now that maybe I should have moved it down. In any case, the point is that for HTTP, you don't need to do this, because we don't have the routing. We haven't done the routing ourselves. And so at some point in the dependency injection, right? So when we have the program, for example, like this one, okay? So I just give it a list of controllers to some library, HTTP4S in our case, and it's going to pattern match on the menu, so to say, for me, okay? So I actually did split up those controllers, okay? So as you can see, this is a list of controllers. A controller for HTTP is just something that has routes, okay? And so and there is actually a controller for insert for HTTP, okay? So it's like this one, okay? So I basically just like took out the create portion, and also I believe like this to local datetime, I actually did like a little bit of drying things up, and because Scala 3 has top level methods, it was actually kind of cool, right? So I just removed this part. So if we go over here, I'm going to see that there's like a common, and then we have like the CRUD controller, and we have the insert controller. The insert controller is now like this tiny thing. I just took out like this one route, that does the creation. And then in the end, in this program, I just like throw them all in there, and and it's going to work out. Let's wrap this up here. On one hand, I'm generally happy with how it turned out. However, in production, probably I would not do this for the CRUD use cases. I believe the CRUD use case is a little bit special, and so I think I ended up with more code, and I actually didn't gain anything. I probably would just like rename them somehow differently. Remember how I said in the beginning, I just want to have like a package insert, and inside of it do. There's no need to do this. I could have just called it somehow differently. Let me actually show you one thing. So there is somewhere a suite for the in-memory gate. Okay, so I believe this one for inserting. Yeah. So the thing is that like when I'm inserting, I actually need to read stuff out from this in-memory database. And so for this, I ended up needing to construct both gates, which is fine again, because like looking up is fine, but still I found it like a little bit weird that when I'm testing like one gate, I actually need another one. In any case, I hope you liked this video, and I see you in the next one. For now, as always, it's been Vlad from devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you wish to support tech education, please consider support me on GitHub sponsors or Patreon, whichever you prefer, and also watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.